That being said, yeah, so basically this talk's moving from sidechains to parachains. I'll be using slides and doing as much as I can here. I've got a pretty deep understanding regardless, so we'll jump right on in. Oh, yeah, thanks. Cool. Hello, hello. Hi. Yeah, so ChainSafe, real quick, great introduction, thank you. Basically, as you said, we're about 22 people based out of Toronto. We're mainly a dev shop and consultancy and do a lot of open source stuff. For instance, we do work on ETH 2.0, which we call lodestar, it's a JavaScript implementation. Go PRE, we brought the Goerli testnet. We birthed that at ETH Berlin back in September. And our own personal bridge, basically using some of the paradigms from the parity bridge that we've built ourselves. So just quick, lodestar is TypeScript implementation of the beacon chain. We've built a bunch of custom modules for it, simple serialize, BLS, and gossip sub, and helping contribute to the libp2p stack. Similarly, for PRE though, or for our work on Polkadot, which we're basically building the Go implementation of the Polkadot runtime environment. We're helping out the Go libp2p stack, which is great because we're also, with our efforts in ETH 2.0, we're able to chat with those guys and help on it. We're building Life, which is basically the WASM interpreter for the PRE stack, and Grandpa, which is basically the Polkadot consensus algorithm, or mechanism, sorry, and we'll be working on that within the PRE ecosystem, and building the solidandgo. Goerli testnet, for those of you that don't know, is just cross-client proof of authority testnet, and it was the first of its kind. And Chainbridge, as I said, is basically a blockchain bridge written in Go that takes similar paradigms from the Polkadot, sort of the parity bridge. Basically looking for, it's a piece of software that runs independently and listens for events from one chain and then into a deposit contract, and then reflects that into another chain specified based on how the smart contracts are built. And I'll jump into that a bit more as we talk about kind of like how, kind of the theme of this moving from sidechains to parachains. Basically, over a year ago, at ChainSafe, we implemented our first sidechain for one of our clients. And that kind of started our evolution into getting into sort of like protocol level work. And basically, you know, when you get a sidechain, what you do is you basically traditionally take a fork of Ethereum. In our case, we've done both parity and geth. You know, we make whatever changes we have to on the core, on the chain to, you know, speed up transactions, or, you know, instead of proof of work, we use POA. And then we create a bridge, or use a bridge, to basically allow the mainnet Ethereum to communicate with our sidechain inversely as well if we want to transfer assets, arbitrary data, tokens, or native fuel. Essentially giving you like a wrapped ether. And so the idea behind bridging is you take, basically we deploy two smart contracts and have a piece of software that listens to them both. They have deposit and withdraw functions that basically hold whatever you send in, whatever data. For an example, if we use ERC20 tokens or Ether, you could basically deposit Ether into one of these testnets, into the bridge, and get it basically emits an event, and then a valid signers would basically are on the bridge looking for these events and then transmit the data across onto your sidechain. Big use case in this is from the XDAI chain, for instance. If you've seen that, what happened at ETH Denver, they did that. Basically, what the XDAI chain does is that exactly. And it was basically a year and a half ago. This was like basically one of the best ways to essentially, you know, layer 2 kind of scale outwards. Before we started seeing a lot of plasma and state channels. You know, some examples of why we needed these type of things was, let's say you wanted a local community governed by a blockchain. they probably need a unique consensus algorithm, interruptibility to some degree so they can transfer assets back and forth. Maybe they want to basically post state from their sidechain back onto the main net Ethereum so that they can ensure that if anything does happen to theirs, they have checkpoints of what their state looked like by basically creating like super Merkle headers of block roots. So, every, let's call it 50 blocks on your sidechain, you would then compose those into a super header and then post that onto the main chain. And then that way you could prove it backwards to regenerate your state, so if you had to. High transactions per second, obviously, is like an important one. Yeah, I've kind of covered that already. Another one, like interruptibility of like actually the assets. We can take essentially Ether, as I was saying, wrap it, turn it into a wrapped Ether, and use this on the sidechain. Again, like a great example of this is how in the ETH Denver, they basically took real DAI, they wrapped it into what they called XDAI, or essentially wrapped DAI, which is a one-to-one conversion from mainnet to the sidechain, so that you can then go and use these assets in a faster environment. It's still safe in the sense that if you're using POA, then we continue to have proof of authority, we continue to have the security there. Sorry, I read these slides over like a few hours ago, and I'm just like, I keep on talking ahead. Right, so what we did. Basically, this project that I was talking about earlier, we ended up taking a fork of Geth, making a bunch of modifications down into the protocol layer. We basically injected, like an example of why we did this, we basically injected ran a Postgres instance alongside the blockchain, so we could have quicker queries similar to like Etherscan style quickness, speed. But basically what happened is as blocks are validating and getting sealed on the actual nodes themselves, we were writing to this database. And the other thing was we need to transfer assets, so we took the parity bridge and basically we're bridging them together. And also, as it says, we're in the middle of getting this audited, but we also created like a modified proof of work in which it's like authority-based proof of work to basically scale them up until they have enough hash power to then switch back to regular proof of work. But through all this stuff in the last year, we realized there were a few issues. Consensus, we need more modular consensus, hot swappable consensus within these sidechains. Right now, it's really difficult. You have to implement your own sort of swapping mechanism to if you want to implement a change consensus halfway through. And basically, with that in mind, if we can get that and achieve that, then we're going to get you can have a blockchain that works you can have solutions that work for you very well. So, interruptible attestation network. This is, I might have actually skipped ahead. So basically, another example of the sidechain. So this is actually the one client work that we've been working on. And basically, we did a few things. We needed the sidechain because we were running a very expensive Merkle tree calculations on the smart contract level. So we basically had to implement our own Merkle tree opcode into Geth, into Sol-C, into Solidity, Remix, to make sure that we could actually run this opcode. So we were forced to go to a sidechain simply so that we could make these proofs happen on-chain versus having to do some sort of off-chain relay or oracle. And basically, we still needed to have the support from the mainnet so we could actually move things around. And basically, that's why we still had to use bridges. And that's when we came up with auth-hash, which is what I told you earlier, which is basically, it goes from kind of proof of work in which it's only a subset of minor addresses are allowed to actually sign and seal blocks as accepted within the network, and then we can turn that off on demand when there's enough hash power actually being spun up on the network, because proof of work was the chosen one for that use case. And basically, making it interruptible across multiple networks is super important. I'm gonna jump into Polkadot. All right, so lessons learned from that one. You know, more modular blockchain components were like really needed because of the modifications we had to do. The hybrid model was like kind of possible, and we realized it actually can work. You like a hybrid consensus. And you know, we did make some PRs, which was nice. For instance, Control S to just recompile. That was fun. But basically, anyway, this is why when we saw Polkadot, we were like, okay, this makes a lot of sense. Because basically, they have a vision for a heterogeneous multi-chain framework. What that kind of means is we have this concept of parachains. Basically, we have this relay chain that has the main support and the security on the network. And basically, the parachains run as underneath it and use the security of the relay chain so that they can, you know, if they only have a few people actually interacting on it, they don't have to worry about compromising the security of their chain. A parachain is simply like a sidechain, as I was explaining. But in the Polkadot ecosystem, it's connected back upwards, which gives a ton of security back to your sidechain, your parachain, sorry. So there's this idea of like Ethereum as a parachain. Basically like a trust-free bridge to Ethereum and back again, allowing you to put transactions. You're allowed to basically, with the idea of like routing transactions through parachains back into Ethereum. So this would be the same way as I was kind of talking about how, you know, we had all these issues where we needed to use this sidechain, but we wanted like to still use the mainnet as like our main point of security. With Polkadot, we can actually achieve that through parachains because it's built for interoperability amongst chains right out of the gate. So basically, there's a few like obviously structural issues around like how the validator is set up needs to be done within the consensus process. But a proof of concept can be built following the model I kind of explained, and basically, which is great, is you know, you can be doing low throughput through this chain. You can have like, in theory, not many validators actually running. If you want to think of like miners, right, in a traditional like sidechain. But because we're using the relay chain, you benefit the security of the entire network, right? So that's why this is like so much better, because we are forced to use something like proof of authority on these side chains, where now we can use basically any consensus we want on our parachain, but still maintain security back up via the relay chain, which to us was like a huge benefit for, you know, making a transition from going from continually building sidechains to moving into more in the parachain space. Another idea would be like a trust-free Bitcoin bridge. You know, like a two-way peg functionality that would basically allow you to, there's like two possibilities here, like with a threshold of signatures, kind of POA style, or you could alternatively do like an N of M multi-signature Bitcoin account with SPV proofs and specialized fishermen to basically allow you to do transfers from like Bitcoin into like a parachain Polkadot ecosystem. Yep. Right. So basically, to just cover a few like basic stuff here, like, is Polkadot designed to replace, you know, Ethereum? No, that's not the goal here. The goal here is to allow a framework so that like these new blockchains can be created, and so that, you know, existing ones can still benefit from the Polkadot ecosystem. And that's a big thing that there's like a lot of controversy around. I find if you like, you know, you go to Reddit or other websites, social medias, you find people like making this complaint. In reality, you know, they can work together. Like, is it, yeah, it is like the token like designed to replace X cryptocurrency, and it's like similar thing. Like all these are to work together, and yeah. Okay, sorry, end of presentation. Slide-wise. So basically, TLDR of basically what we're trying to get at here is we've been building using sidechains for clients a lot outside of our open source, and basically every time we have to go implement, we have to get really unique in our implementation because of the requirements of the client. Moving towards parachains and looking at the future of what parachains look like, we start seeing that there's a lot more value in them because of how modular we can get this and we can build with them. We can basically change all sorts of configurations, not compromise security, not have to worry about, who are my authorities, who's mining on this network if it's POW, right? We don't have to deal with like obscure, centralized bridging mechanisms, because ultimately, like when people say, hey, we have a bridge from Ethereum main to a sidechain, that bridge is technically centralized, right? There are a set of authorities, basically a set of private keys that are allowed to sign on behalf on the contracts on either side, and they're the ones actually doing the transfer. So you have to put trust that the people running the bridge and maintaining them are actually acting in their best interest, in your best interest. And as we move to the idea of Polkadot having these parachains, it's built in. It's out of the box. You have the messaging between them allows you to essentially, parachains look like a tree structure. I actually forgot to bring this up, but basically, like, you have your relay chain at the top. You can have, like, let's say 2 parachains, and the 2 parachains can each have another 2 parachains connecting to them, and they all benefit upwards. And the idea is that these parachains can communicate with each other freely, without kind of hiccups, because that's the design of the Polkadot framework and the ecosystem. Which is a huge benefit because we don't need this centralized kind of bridge, which is acting essentially as a relayer of information back and forth. Thanks for taking the time. I know I'm not Aiden, and I hope I at least got some of his message across. And we will be speaking, I think, on Thursday at the Web3 track, I think. And he'll definitely be giving a more in-depth version of kind of what I just gave you, as well as we'll be doing some other stuff and talking about some other things. Thank you again. Questions? Yes. Sorry, like are you saying like the structural overview kind of look? Yes. Yes. Yeah. So there is one. So the question was basically, what I kind of described was like, hey, that looks a lot like Plasma. Yes, 100%. Caveat: Plasma does not support smart contracts. It's transaction based. I don't know if there's any future. I'm not too sure about the Plasma research, but I do know that essentially it's transactional based right now, which means that you don't actually get the same benefit as a sidechain. You get the benefit of like high transaction throughput without the actual smart contract functionality of it. That's where Polkadot parachains, you actually get like a sidechain that is, yes, kind of the structure looks very similar to Plasma. Some also say the structure looks kind of similar like in an ETH 2.0 in the sense because we have the beacon chain. The beacon chain is kind of like a relay chain to a certain degree, but it gets different as soon as we go parachain to shard chain. Yeah. Yes? Relay chain is basically class structure, easiest way to think about it. Parent is relay chain, parachains are child chains, and basically the parent, let's think of it as like a leash on the parachains, knows what's going on, and keeps them safe. Yeah. Sidechains are sidechains are a concept within the Ethereum ecosystem, ecosystem that we've been doing for a long time now. Sorry. Which basically the idea is we take like Geth, change up a few parameters within it, or parity, for instance, and we change a few parameters within them to suit whatever the needs are of that project, and then we're basically running an Ethereum chain, just like in our own private ecosystem, or public ecosystem, for that matter.
So you can have a transaction that happens on the sidechain, and then ultimately it can end up on the main Ethereum.
Yeah, I mean, you could bridge them one-to-one, or you can do what I talked about earlier, which is basically building super Merkle headers by basically collapsing like 50 blocks into a Merkle root, and then posting that Merkle root via bridge back to the mainnet Ethereum. Two different ecosystems. One, like Parachain's Polkadot, like the notion of the sidechain is still technically within Parachain. The main difference is, in the Polkadot ecosystem, when we talk about sidechains, it's a parachain, and this parachain basically benefits security off of the relay chain, and the relay chain monitors all parachains. Whereas in, Ethereum mainnet doesn't actually know what's going on in a sidechain, right? For instance, XDAI, they don't know XDAI. It does, like mainnet Ethereum isn't aware of XDAI. The relay chain is aware of the sidechains, of the parachains. We can talk more after. Yes. Yeah.
So you just mentioned that the main chain, we don't know anything about the parachain, but like Ethereum doesn't know what the state of the parachain.
Yes. Yeah. Well, this like if you were to spin up a side chain, they wouldn't know. Yeah.
But parachain A would know the state of both the Ethereum as well as parachain B state. So like, for example, if I deploy some smart contract in parachain A, and on parachain B, I want to send some transaction based on the state of parachain A.
Yeah, so we can do like message passing between parachains. So you could pass like via messages to the other parachain, like what that state looks like.
Yeah.
Yeah.
So it's possible, basically.
Yes.
Okay.
I think I understood your question. It's possible to do message passing. Parachains are able to communicate with each other. Yeah. Cool. If that's it, thank you guys. Thank you.
Thanks, Greg. So next we have Antoine. He's coming all the way from Australia to give a talk on Speckle OS and